Hello, welcome back. Today we are here to discuss about the question called given an array of integers ARR, we need to return true if and only if it is a valid mountain array. So this is a question from lead code. So you can see the question. Let me give you an example here and let's discuss on this. Okay. So given an array of integers, we need to return true if and only if it is a valid mountain array. If it is a valid mountain array. So you guys know how mountain looks, right? So this is a plain land. It will go uphill like this. It will come downhill like this. So this is called as a valid mountain. So it should go uphill. It should come downhill, right? This is we call as mountain array. Mountain. Okay. Now the same we should do it with the array of numbers too. So what they are saying, let's see. Array is a mountain array if and only if array dot length is greater than or equal to 3. So what they are saying with this point is array elements length should be greater than or equal to 3. So if I have any array less than 3 size, this array is not considered as a mountain array. So this is a very simple step. So if I have any two elements like 1 comma 2, this is not a mountain array because that is what the condition is, right? So I hope this is clear. Now, what is the next one? There exists some I with 0 less than I less than array dot length minus 1 such that array of 0 less than array of 1 less than somewhere array of I minus 1 less than array of I, and after that array of I greater than array of I plus 1 greater than array of I plus 2 greater than array of array dot length minus 1. Okay, so I know this is bit tricky. Let me explain you clearly what this point is. So what they are saying is in the given array, so let me take an array, guys. Okay, let me scroll up and show you what exactly they're saying. Okay, so this example is a mountain array. So let me explain you with this points. So there will be a point like this in the array where all the elements on the left side, all the elements of the left side are strictly increasing. Strictly increasing means if you take any pair of elements, they are in increasing order. They are in increasing order, which means left side element in the pair is always less than right side element. Left side element is always less than right side element. This is what they are saying. So if you take any pair from the left side, it should be strictly increasing. The left side should be strictly increasing, and right side of this point will be strictly decreasing, which means if you take any pair, okay, 2 comma 1, 1 comma 0, if you take 1 comma 0 or 2 comma 1 or 5 comma 2, okay, 5 comma, okay, so sorry, okay, 5 comma 2, if you take any pair like this, okay, they should be strict. How they should be is left side element should be greater than right side element, which means strictly decreasing order. Strictly decreasing is nothing but what, guys? If you take any consecutive pair, left side element is always greater than right side element. That's already simple and straightforward one. Okay, I hope the question is clear. So now let me discuss with you about different. So we all know a mountain will be going uphill straight and coming downhill straight. Okay, now what I was saying is, okay, let me show you one more example what they have given. So now if you take this array, we'll take the same point, but if you take on the left side, 0 is great. Sorry, guys. 0 is less than 2, which means this pair is strictly increasing. 2 is less than 3. This pair is also strictly increasing. Now, if we take 3 and 3, 3 is equal to 3. That is not less than 3, which means that is not strictly increasing. This particular pale is breaking our rule. So increasing order, but not strictly. That is what they are saying. Now, left side itself, it is not increasing. So what is the use of checking on the right side? So this is not a mountain array. This is one of the examples. So what we have to understand here is the array should be strictly increasing. Strictly increasing. Okay. Till where? Till a particular point. After this point, what it will be? It will be strictly decreasing. So initially the array will be strictly increasing. After this particular point, this will be strictly decreasing. That's what the mountain is. I hope this is clear. Now, let me give you an example. Now, you guys say me. Okay. Oh, so sorry. I'll give you an example. 3, 2, 1. Is this a mountain array? Say me, guys. Is this a mountain array? Obviously, this is not a mountain array. Why? Because if you take these three elements, they are strictly decreasing. If this is a plain land, we just have a slope, but we don't have any uphill to go to top of the hill, right? So this particular example is not a mountain array, which means we don't even have an increasing order first. What they're saying in the question clearly, they're saying is there will be a point, there should be a point, okay, in an array, and that before that point it will be increasing, after that point it will be decreasing. That's what the thing is. If we don't have that point itself, it doesn't matter. That array is not a mountain array. That's all. Now, okay. So how we will solve this? We obviously know how we will solve this is very simple thing. So what we'll do, we will simply, so we know one thing we know in sure is this: when we are starting from the zeroth index, what we need to make sure, if you take any two values, they should be increasing order. They should be increasing order. Okay, let's take 0 and 2. 0 and 2, they are increasing order or decreasing order? How I can say increasing order? Left side value should be less than right side value. So 0 is less than 2. True. Now let's take one more pair. What is the next pair, guys? What is the next pair? The next pair is 2 and 2 and 3. Is it stick increasing? Yes, correct. This 2 is less than 3. Now let's take 3 and 4. This is also increasing. Now let's take 4 and 5. This is also increasing. Okay, good. Till now, till 5, what we observed is till 5, till this particular length, this is strictly increasing. Right, this is strictly increasing. Now I'll compare 5 and 2. Is this 5 less than 2? Obviously no. Obviously no. So what I can understand here, okay, this is the top of the hill. Okay, I have climbed towards top. Now I reached here. I find a slope, which means this is the top of the hill, right? So after this 5, how my elements will be? How my elements will be? My elements will be in decreasing fashion. After this particular 5, my elements will be in decreasing fashion. Okay, so till 5, I'll compare whether it is increasing or not. Once I get some non-increasing pair, which is a decreasing pair like this 5 and 2, I will stop comparing for increasing. I will instead check for decreasing. So 5 is greater than 2, true. 2 is greater than 1, 2, and 1 is greater than 0, true. And I reached the end of the list, which means this array is an mountain array. This array is an mountain array. That's all. Pretty simple one. Okay. Now, now let's take one more example, guys. Let's take with the same approach, we'll take one more example. 1, 2, 3, 4. This is the array. Now you guys say me, is this a mountain array? Obviously, no. Why? We are going uphill. But from here, what we will do? We will jump into this or what? No, right? This is the uphill. We don't have a downhill to come down off the hill. So for that, how you will say with our approach, how we can decide whether it is a non-mountain array? We'll see. So what we are doing? We are comparing the first two elements. Is this a pair in increasing order? 1 less than 2? True, yes. I'll compare the next pair. 2 and 3. 2 less than 3, yes, it's an increasing order. I'll compare the next pair. 3 less than 4, yes. Now I only have 4. I don't have any pair, which means I reached the end of the list. Okay, I reached the end of the list, but I just keep on checking increasing order and I reached the end, which means what I can decide here, oh, I didn't even go downwards. I didn't went downhill, which means this is not a mountain array. That's all. So when you are checking for increasing order, if you reach the end of the list, that means this is a dead end. This means that is not a mountain array. That's all simple. Is this clear, guys? I hope this is clear. So now let's jump into code. Okay. Now let's take int. I will be starting from 0. Int n will be array dot length. Array will dot length. Now what I will do? The first thing is I need to check from the beginning. What I need to check? I need to check whether it is a first thing. I should not go out of my range. I should be less than n minus 1. And and my elements array of I less than array of I plus 1. Right? Yes or no, guys? What I'm checking here is okay. What we are checking here is we are not going out of my index range. And I am checking for the increasing order, which means left side element is less than right side element. If this is true, what I'll say, simply go for the next pair. Go for next pair. Right. Now, okay. I iterated on this. I came out. What I need to do here, what I need to do, I need to check whether I reached end of list or I haven't started. Should I like there are two things that I need to check. Whether I reached my end of the list or have I started at all? Because there can be elements like this 3, 2, 1. We already saw this example 3, 2, 1. So here, can I start directly on 3? Can I directly jump into 3? No, right? Because this is already a hill. If I draw this 3, 2, 1, it will be like this. How can I start from here and jump onto this 3? That is not possible. So even in that case, we need to make sure we are returning false. If I is 0 or I is less than I is less, sorry, not less than, I is equal to n minus 1. If this is the case, return false. So here what we are doing is we are checking whether I reached the end of the list. This is the condition. Or I haven't even started because directly there is an uphill. I don't even like there is directly there is the top of the hill. I didn't even start it from the first step. So return false. Okay, this condition also failed. Now what I need to check? I need to check for first thing I'll check is whether I is less than n minus 1 or not. And I need to check after that particular point what we need to check whether it is a strictly decreasing. So array of I greater than array of I plus 1. Simple. What are the logic that we have thought? I plus plus. Okay, fine. After the entire thing, what I need to check? I need to make sure I have reached end of the list. If I have reached the end of the list, now I can say, okay, it is increasing and decreasing. If not, I know what I need to do. Simply return false. That's all. Let's run this. Yeah, you can see it got accepted. Let's submit this. And this is the question, guys. So we are simply going uphill here. We are simply going uphill here. What we are doing, we are simply going for the next pair whenever it is in increasing order. Okay, once this is not in increasing order, we are coming out of the loop. We are coming out of this while loop. After that, what we are doing, we are checking whether I have reached the end of the list. Why I am checking the end of the list? Because if my elements are 3, 5, and 7, 3, 5, and 7, I only have uphill here. I don't even have downhill, which means I reached the end of the list. So I should say that is not a mountain. Okay. If I have an array like this, 1, 3, and 5, 1, 3, and 5, what I need to do? What I need to do, 1, 3, and 5. We have to, we will start from beginning. 1, 3, 5. We reach the end of the list. Once we reach the end of the list, I know I need to return false because I only have an uphill. I don't have a downhill. So in this above example, in the above example, we have 3, 5, 7. Okay, this is also same for the uphill. Now, if I have something like this, 3, 2, 1, what it will be 3, 2, 1. I have directly starting from the uphill only. It is only having a downhill. It doesn't have an uphill here. So I haven't even started. Which means it's a not a mountain. That's all. So if both the conditions are not true, now I will check for downhill. Now I will check for downhill. Okay, downhill. So how I will check for downhill? If I take any two elements, let's say 1, 2, 3, 5, 4, 3, 2, 1. If I take any two elements, 5, 4 or 4, 3 or 3, 2 or 2, 1. 2 should be always greater than 1, which means left side element should be always greater than right side element. I is left side element, I plus 1 is the right side element. It is greater than, then increase it. If I reach end of the list now, that means it is a mountain. I successfully climbed it, I successfully came down. So that is a mountain, I am returning true. If not, simply return false. That's all. Right. So this is all the question is about, guys. I hope this is clear. Thank you.